Physical science students, this is Chapter 2, Section 3, so this is Lesson 2.3, and this will be your final lesson for this chapter before we review and take the exam. So let's talk about acceleration, speed, and velocity. As you can clearly see, you should be writing up here in your journal in a different color, or highlighting, or putting a star to the side, the title of this shot, Acceleration, Speed, and Velocity. And you have a vocabulary word, so make sure you write that down and note that it's a vocabulary word. Acceleration is the rate of change of velocity. When the velocity of an object changes, the object is accelerating. So everything you see on the screen, both writing and graph, you will want to make sure that you copy it down exactly how you see it. So next bullet point, a change in velocity can be either a change in how fast something is moving or a change in the direction it is moving. Acceleration occurs when an object changes its speed, its direction, or both. And here you can see we have a graph. It's the speed of Tamara's car, time in minutes, speed in kilometers per hour, and you can see that she's pulling out of the driveway, and then at some point she stops. And then she's slowing down at a red light. She stopped at that light. She's speeding up. She's moving at a constant speed. This means she's in movement. Slowing down to enter the parking lot. And then parking. The heading has changed. Speeding up and slowing down. Writing down, if the acceleration is in the same direction as the velocity, the speed increases. So draw a car, draw acceleration going to the right, velocity going to the right, and the fact that the car is in fact speeding up. So in this slide, you can see just the opposite is happening. Let's take a look at the car. The car is right here. It is in motion. It is still moving forward. However, it says it's slowing down. So if we take a look, our velocity is still going this way, but our acceleration has backed off and has started going the opposite direction. So I hope you're writing down and copying everything from the slide, including this. If the speed decreases, the acceleration is in the opposite direction from the velocity, and the acceleration is negative. Our title has changed, so make note of that. Highlight it, a different color of pen or color pencil, or put a little star at the side in the margin. Calculating acceleration. Please copy this down. To calculate the acceleration of an object, the change in velocity is divided by the length of time interval over which the change occurred. Continue writing. To calculate the change in velocity, subtract the initial velocity, the velocity at the beginning of the time interval, from the final velocity, the velocity at the end of the time interval. Continuing with calculating acceleration. In your notes, copy down this equation for acceleration. Write down in class example. Our problem. A skateboarder has initial velocity of 3 meters per second west and comes to a stop in 2 seconds. What is the skateboarder's acceleration? First, we need to analyze the problem. We know the initial velocity, v equals 3 meters per second west. We also know the final velocity. We know the time, 2 seconds. What's unknown? Acceleration. To solve for the unknown, we have to set up the equation and the problem. So here is where you will write that down. And then with solving the problem through algebraic methods, the acceleration has a negative sign, so the direction is reversed. There is no need to write down the evaluation of the answer. Everything on this slide will need to be written down. The title, Speeding Up. Suppose a car starts at rest and reaches a speed of 80 meters per second as it heads east down the street. Its acceleration can be calculated as follows. Write down slowing down and then the rest of the slide. Now imagine a skateboarder is moving in a straight line with the velocity of 3 meters per second north and comes to a stop in 2 seconds. The final speed is 0 and the initial speed was 3 meters per second. Continue writing, calculating negative acceleration. The skateboarder's acceleration is calculated as follows. The acceleration is in the opposite direction of the skateboarder's velocity when the skateboarder is slowing down. So let's discuss changing direction. The speed of the horses in this carousel is constant, but the horses are accelerating because their direction is changing constantly. Acceleration toward the center of a curved or circular path is called centripetal acceleration. So from here, acceleration toward the center of a curved or circular path is called centripetal acceleration. Write that part down, last sentence. And make a diagram exactly how you see it. This entire screen should be copied. Projectile motion. Anything thrown or shot through the air is called a projectile. Projectiles follow a curved path because they have a horizontal and vertical velocities. The projectile's horizontal velocity is always constant. It has a vertical velocity downward due to gravity.